Hi, hello there. Welcome to Data Models. On this video lecture, we will be talking about data models. This video lecture requires the previous topic, which is the database systems. So if you have not seen the video yet, you can go ahead and check it on the playlist. Now, the learning objectives for this video lecture. In this chapter, you will be able to learn about data modeling and why data models are important, about the basic data modeling building blocks, what business rules are and how they are influenced or how they influence database design. So how the major data models evolved, about emerging alternative data models and the need they fulfill. Also, you will learn how data models can be classified by their levels of abstraction. So let's start with data modeling and data models. So data modeling is the process of creating a data model for the data to be stored in the database. This data model is a conceptual representation of data objects, the association between different data objects, and the rules. Data modeling helps in the visual representation of data and enforces business rules, regulatory compliance, and governance policies on the data. So data models ensure consistency in naming conventions, default values, semantics, security, while ensuring the quality of the data. So data modeling is defined as the iterative and progressive process of creating a specific data model for a determined problem domain. The next term is data model. So data model, simple representations of complex real-world data structures. It is useful for supporting a specific problem domain. So a data model is defined as an abstract model that organizes data description, data semantics, and consistency constraints of data. The data model emphasizes on what data is needed and how it should be organized instead of what operations will be performed on the data. So data model is like an architect's building plan, so which helps to build conceptual models and a set of relationship between data items. So types of database models includes the hierarchical database model, relational model, network model, object-oriented database model, and the entity relationship model. Next is model. What is a model? So model is an abstraction of the real-world object or event. Now let's talk about the importance of data models. Identifying and documenting business rules are very important to database design. So business rules allows the creator to develop relationship participation rules and constraints and to create a correct data model. They also allow the creator to understand business processes and the nature, role, and scope of the data. They are a communication tool between users and creators, and they also help standardize the company's view of the data. So it is important to keep in mind that some business rules cannot be modeled. Okay, so the importance of data models includes, but are not limited to, are a communication tool. It gives an overall view of the database, organized data for various users, and these are an abstraction for the creation of a good database. Okay, so let's talk about data modeling basic building block. So the basic building blocks of all the data models are entities, attributes, and relationships. So let us define each of the term. When you say entity, it is unique and distinct object used to collect and store data. So an entity is anything such as person, place, thing, or event about which data are to be collected and stored. So entities may be physical objects such as customers or products. But entities may also be an abstraction such as flight routes or musical concerts. Attribute. Attribute is a characteristics of an entity. For example, a customer entity would be described by attributes such as last name, customer's first name, or the customer phone number, address, and the customer credit limit. The attributes are the equivalent of fields in file systems. Next is relationships. So relationship describes an association among entities. It could be one-to-many, many-to-many, or one-to-one. So for example, there is a relationship between customers and agents that may be described as an agent can serve many customers, and each customer may be served by one agent. So data models uses three types of relationships as mentioned earlier, and these are 1 to M, M to N or M to M, and 1:1. Database designers usually use a shorthand notations 1:M, okay, M:(n), and 1:1 for them respectively. So although the M to N notation is a standard label for many-to-many relationship, the label M to M also be used. So the following examples illustrate the distinction among the three. Okay? Next would be constraint. What is a constraint? Constraints are a set of rules to ensure data integrity. So example, a student can take a maximum of 2 books from the library is applied as a constraint on the student database. Okay, so that is, or these are conditions applied on the data. All right. Next, how about business rules? A business rule is a statement that imposes some form of constraint on a specific aspect of the database, such as the elements within the field specification for a particular field or the characteristics of a given relationship. You base a business rule on the way the organization perceives the uses of its data. So which you determine from the manner in which the organization functions or conducts its business. Okay? So business rules are brief, precise, and unambiguous. So these are description of a policy, procedure, or principle. Business rules enable defining the basic building blocks and describe the main and distinguishing characteristics of the data. So example, a student can take a maximum of 2 books from the library is an example of business rule and is applied as constraint on the student database. Another example is a student cannot have more than 2 instruments checked out at the same time. Okay? Or a ship date cannot be prior to an order date for any given order. Okay? So these are examples of business rules. Another are departments offer courses. Courses generates class. Professor teaches a class. So these are all examples of business rules. Next is discovering business rules. So business rules gives the proper classifications of entities, attributes, relationships, and constraints. So sources of business rules are managers, okay, company policy makers, department managers, written documentation, procedures, standards, operation manuals, and interview with end users. Okay, so these are all sources of business rules. Now, there are several protocols to the way business rules are written. Not every protocol has to be followed, but in general, a well-written set of business rules consists of having a unique identifier, describes one or one and only one concept. are written in plain language, are written and from a single source. So in terms of a unique identifier, business rules should come with an identifier that may consist of the rule number and the department it affects. Okay? So the reasons for identifying and documenting business rules are it helps standardize companies' view of the data, communication tools between the users and designers, and allows the designer to understand the nature, role, scope of data, and business processes. Develop an appropriate relationship participation rules and constraints, and create an accurate data model. The next one is translating business rules into a data model components. So the rules are, it would depend, but the reference that we're using uses nouns translate into an entities. Verbs translate into relationships among entities. The relationships are bidirectional. Okay? So questions to identify the relationship type, how many instances of B are related to one instance of A? How many instances of A are related to one instance of B? So these are all examples of questions to identify the relationship type. For the naming conventions, entity names are required to be descriptive of the objects in the business environments. So use terminology that is familiar to the users. So attribute name required to be descriptive of the data represented by the attribute. So proper naming includes facilitates communication between two parties, two or more parties, and promotes self-documentation. Now let's talk about the hierarchical and the network model. So we have here an example of hierarchical model. Okay. So hierarchical model, this database model organizes data into a tree-like structure with a single root to which all the other data is linked. So the hierarchy starts from the root data. In this example, is a college and expands like a tree. So adding child nodes to the parent nodes. So in this model, a child node will only have a single parent node. This model efficiently describes many real relationships like index of a book, recipes, etc. In hierarchical model, data is organized into a tree-like structure with one-to-many relationship between two different types of data. For example, one department can have many courses, okay, many professors, and of course, many students. So the advantages and disadvantages of the hierarchical model. Advantages includes promotes data sharing. Parent-child relationship promotes conceptual simplicity and data integrity. Database security is provided and enforced by the database management systems or DBMS. So hierarchical model is efficient with one-to-many relationships. Now, some of the disadvantages includes it requires knowledge of the physical data storage characteristics. Navigational system requires knowledge of hierarchical path. So changes in structure requires changes in all the application programs. Implementation limitations, no data definition, and lack of standards. So the next model is the network model. So this is an extension of the hierarchical model. So in this model, data is organized more like a graph and are allowed to have more than one parent node. So in this database model, data is more related as more relationships are established in this database model. Also, as the data is more related, hence accessing the data is also easier and fast. So this database model was used to map many-to-many data relationships. So this was the most widely used database model before the relational model was introduced. Now, let's discuss the advantages and disadvantages of a network model. So, advantages includes conceptual simplicity, handles more relationship types, data access is flexible, data owner or member relationship promotes data integrity. It has a conformance to standards, includes data definition language or DDL and data manipulation language or DML. Now, the disadvantages includes system complexity limits efficiency. Navigational system yields complex implementation, application development, and management. Structural changes require changes in all the application programs. All right. Okay, so we're done with the discussion of the hierarchical and network model. Now let us compare and contrast the two. So hierarchical and network models compared. So for the hierarchical, it manages large amounts of data for complex manufacturing projects. That is where hierarchical model is most applicable. Network model represents complex data relationships. Hierarchical, represented by an upside-down tree which contains segments. So segments is equivalent to a file system's record type. For the network model, improve database performance and impose a database standard. So hierarchical model depicts a set of one-to-many relationships, while the network model depicts both one-to-many and many-to-many relationships. Okay, so let's talk about the standard database concepts. So what is a database schema? So schema is defined as the conceptual organization of the entire database as viewed by the database administrator. A database schema represents a logical configuration of all or part of a relational database. It can exist both as visual representation and as set of formulas known as integrity constraints that govern a database. So these formulas are expressed in a data definition language such as SQL. So as part of the data dictionary, a database schema indicates how the entities that make up the database relate to one another, including tables, views, stored procedures, and more. So you also have subschema. Subschema is a portion of the database seen by the application programs that produce the desired information from the data within the database. Now, typically, a database designer creates a database schema to help programmers whose software will interact with the database. The process of creating a database schema is called data modeling. So when following a tree schema approach to database design, this step would follow the creation of a conceptual schema. So conceptual schemas focus on the organization's informal needs rather than the structure of the database. So there are two main kinds of database schema. So a logical database schema, which conveys a logical constraints that apply to the stored data. It may define integrity constraints, views, and tables. Okay, so a logical schema includes entities, attributes, and relationships. So a physical schema or a physical database schema lays out how data is stored physically on storage systems in terms of files and indices. So at most, okay, so a database schema indicates which tables or relations make up the database, as well as fields included on each table. Thus, the term schema diagram and entity relationship diagram are often interchangeable. Okay, so another standard database concepts aside from schema and subschema are the DML and the DDL. So you will often hear this word in database systems. So when you say DML, It stands for database or data manipulation language. This is an environment in which data can be managed and is used to work with the data in the database. So DDL is data manipulation language and is used to manipulate data, as the name implies. So examples of DML are insert, update, and delete statements from the SQL. Okay, so its usage, DML statement is used to insert, update, or delete the records. So classification, so DML is further classified into procedural DML and non-procedural DML. Now, the next term is DDL, or the data definition language. So DDL statements are used to create database schema, constraints, users, tables, etc. So DDL has no further classifications. So example of commands that is considered to be a DDL are create, drop, rename, and alter. Okay? So DDL enables the database administrator to define the schema components. Next is the relational model. Okay? So the relational model produced an automatic transmission of database or database that replaced standard transmission databases. So it is based on a relation. Okay? So when you say relation, this pertains to a table. Okay? Relation or table is the matrix composed of intersecting tuple and attribute. So tuple means a row and attribute means a column. So we will be talking more about relational model on the next video lecture. For now, we are just going to introduce different data models. Okay? So the relational model describes a precise set of data manipulation constructs. So in this model, data is organized in two-dimensional tables and the relationship is maintained by storing a common field. Okay, so this model was introduced by E.F. Codd in 1970, and since then, it has been the most widely used database model. In fact, we can say that the only database model used around the world. So the basic structure of data in a relational model is tables. So all the information related to a particular type is stored in rows of that table. So hence, tables are also known as relations in a relational model. Okay? In the coming lectures and video lectures, we will learn about how to design tables, normalize them to reduce data redundancy, and how to use structured query language to access data from tables. So these are the advantages and disadvantages of a relational model. So advantages includes structural independence is promoted using independent tables. Tabular view improves conceptual simplicity. Ad hoc query capability is based on the simple query language, okay, or SQL. So isolates the end users from physical level details and improves implementation and management simplicity. Now, disadvantages includes requires a substantial hardware and system software overhead. So conceptual simplicity gives untrained people the tools to use a good system poorly. And it may promote information problems. Okay? Next, let's talk about the Relational Database Management System or RDBMS. Okay? So RDBMS, as many called it, performs the basic functions provided by the hierarchical and network DMS systems. So it makes the relational data model easier to understand and implement. It hides the complexities of the relational model from the user. Okay? So RDBMS stands for the Relational Database Management System. So RDBMS is the basis for SQL and for all modern database systems like MS SQL Server, IBM DB2, Oracle, MySQL, and Microsoft Access. So a relational database management system or RDBMS is a database management system, DBMS, that is based on the relational model as introduced by E.F. Codd. Now, here's an example of a relational database management system. This is a relational diagram here, wherein the agent shows a one-to-many relationship with the customer. So it simply means that an agent could have multiple customers involved. Okay? And these multiple customers could only have one agent involved. All right? This is how we read it. One is to many relationships. So we've got one to many relationship. Okay? So we will be covering more of a relational database management system on the next video lecture. So the next one is an SQL-based relational database application. So SQL relational database application involves three parts. So you've got the end user interface, collection of tables stored in the database, and the SQL engine. So the end user interface allows the end user to interact with the data. Basically, the interface allows the end user to interact with the data or by automatically generating SQL code. Each interface is a product of software vendor's idea of a meaningful interaction with the data. So you can also design your own customized interface with the help of application generators that are now standard fare in the database software arena. So the next one is the set of tables stored in the database. So each table is independent from another. Rows in different tables are related based on common values in the common attributes. A collection of tables is stored in the database. In a relational database, all data are perceived to be stored in tables. The tables simply present the data to the end user in a way that is easy to understand. So each table is independent. Rows in different tables are related by common values in common attributes. Okay? So the last component is the SQL engine. So where it executes all queries. The SQL engine, largely hidden from the end user, the SQL engine executes all queries or data requests. So keep in mind that SQL engine is part of the RDBMS software. The end user uses SQL to create table structures and to perform data access and table maintenance. So the SQL engine processed all user requests, largely behind the scenes and without the end user's knowledge. Hence, SQL is said to be a declarative language that tells what must be done but not how. Okay? So that's SQL engine. Now let's have an overview of the entity relationship model. So ERD, or the entity relationship diagram, or also known as the entity relationship model, it is a graphical representation of entities and their relationships in a database structure. ERD uses graphic representations to model database components. So entity instance or entity occurrence, these are rows in the relational table. Okay, so connectivity is the term used to label the relationship types. So in this database model, relationships are created by dividing objects of interest into entity and its characteristics into an attributes. So different entities are related using relationships. So the ER model are defined to represent the relationship into a pictorial form to make it easier for different stakeholders to understand. So I have here an example of the entity relationship model. So this model is a good to design database, which can then be turned into tables in relational model. Okay, so let's take, for example, if we have to design a school database, then student will be an entity with attributes name, address, age, student ID, and other attributes of a student. So as address is generally complex, It can be another entity with attributes street name, pin code, city, etc. And there will be a relationship between them. Okay, so relationships can be of different types. Now let's talk about the advantages and disadvantages of the entity relationship model. So advantages includes visual modeling yields conceptual simplicity. So visual representation makes it effective communication tool. This is integrated with a dominant relationship model or relational model. Okay, so disadvantages includes limited constraint representation, limited relationship representation, no data manipulation language, and loss of information content occurs when attributes are removed from entities to avoid crowded displays. Now we have here different notations used on the entity relationship model. So it's either the Chen notation and the Krauss-Foot notation. Okay, so let's have an example here. So below is a one-to-many or one-to-M relationship. So you've got painter, this is an entity, okay? And you have here painting, another entity. Okay? So a painter can paint many paintings. So each painting is printed by one painter. So that's how you read it. Okay? So a painter paints multiple painting, and each painting is painted by one painter. So in Chen notation, we use this symbol. Okay? So painter paints painting. So you've got the noun, okay, is an entity. All right? So in Krauss-Foot notation, we are using the symbol here. You've got painter paints painting. So if you have seen this symbol here, this means one to many. Okay, you've got one to many. So painter paints painting. And each painting is painted by one painter. So in UML class notation diagram, this is the notations used. You've got painter, okay, 1:1 or 1:many to painting. Okay, so something like painter paints painting, and painting is painted by a painter. Okay, so the first line here is an example of one-to-many or one-to-M relationship using the Chen notation, the Krauss-Foot notation, and the UML class diagram notation. So we will be talking about and discussing more of this notation on the succeeding discussions. So another example of one-to-many, or many-to-many, okay, M-to-N relationship. So an employee can learn many skills. Each skill can be learned by many employees. Okay. Now, to use Chen notation, you'll have employee learns skill. Okay. So it means an employee can learn many skills, and each skill can be learned by many employee. That's many-to-many relationship. Now, using the Krauss-Foot notation, okay, so you've got employee, you've got this many-to-many notation. Okay, so employee learns skill, and the skill can be learned by many employees. Okay, and UML notation, you have the same. Okay, employee learns skills, and skills learned by employee. All right, now to depict a one-to-one relationship, you could have employee manages store. So this is 1:1. Okay, employee, this is a notation for Krauss-Foot 1:1. Okay, employee manages store. And using the UML diagram notation, you've got employee manages a store, and the store is managed by an employee. So we have a one-to-one relationship. So we will be covering more details about this ER model notations on the next video lecture. So for now, it will just give us an overview of what and how ER model model the data. Okay. Next is Oriented Data Model, or OODM, or also known as the semantic data. Okay. So the Object-Oriented Database Management System, or OODBMS, is based on OODM, okay, or the Object-Oriented Data Model. So the object contains data and the relationship with operations that are performed on it. So basic building block of autonomous structures. So there is also what you call abstraction of the real world entity. So the attributes describes the properties of an object. So increasingly complex real world problems demonstrated a need for a data model that more closely represented the real world object. Okay? So in the object-oriented data model, or OODM, both data and their relationships are contained in a single structure known as object. In turn, the OODM is the basis for all the object-oriented database management systems, or OODBMS. Okay? So components of the object-oriented data model. So an object is an abstraction of the real-world entity. In general terms, an object may be considered equivalent to ER model's entity. So more precisely, an object represents only one occurrence of an entity. So the object semantic content is defined through several of the items in the list. Okay? So attributes. Okay? So attributes describes the properties of an object. For example, a person object includes attributes name, social security number, and date of birth. All right? So objects that are similar characteristics are grouped in classes. A class is a collection of similar objects with shared structure or attributes and behavior or methods. So in general sense, a class resembles the ER model entity set. However, a class is different from an entity set that it contains a set of procedures known as methods. So a class method represents a real-world action such as finding a person's name or selected person's name, changing a person's name, or printing a person's address. In other words, methods are equivalent of procedures in traditional programming languages. In OO terms, or object-oriented, methods define the object's behavior. So classes are organized in class hierarchy. The class hierarchy resembles an upside-down tree in which each class has only one parent. So for example, the customer class and the employee class share a parent person class. So note the similarity to the hierarchical data model in this respect. So inheritance is the ability of an object within the class hierarchy to inherit the attributes and methods of a classes above it. For example, two classes, customer and employee, can be created as subclasses of the class person. So in this case, customer and employee will inherit all attributes and methods from person. So it might sound too technical for you, but okay, so if you have already, or if you are already done with object-oriented programming, then you know what I'm saying. So if not, well, this is just an overview of an object-oriented data model. But the focus of the information management is more on the relational database model. Okay? Okay, so what are the advantages and disadvantages of an object-oriented data model? So advantages includes semantic content is added. Visual representation includes semantic content. Inheritance promotes data integrity. Slow development of standards cause vendors to supply their own enhancements. So you've got a compromised, widely accepted standard. Complex navigational system. Learning curve is steep. High system overhead slows transactions. So these are the disadvantages of OODM. Okay? Now I have here the comparison of the object-oriented, the UML, and the ER model. That's what I'm saying. We are going to focus on the ER model. So for the sake of discussion, we have included other data models on this chapter. All right. So for instance, you'll have the object representation. Okay. So say this is an invoice. Okay. Your invoice has date, invoice date, invoice number, invoice ship date, and invoice total. Okay. So the relationship is 1:many, customer and line. Okay. In a UML class diagram, we could say that customer generates invoice. Okay. And invoice has line. Okay. We could read this as line belongs to invoice and invoice belongs to a customer. Okay, so this is the UML class diagram representation of the object presented here on the left. Now, if we are going to use an ER model, so this is how it looks like. A customer generates invoice. So you've got this 1:0, okay, relationship. Okay, or it could be 1:none. Okay, because customer can also not generate an invoice. All right, so you got here the cardinality 0:many. All right, so we will be talking more about the ER model on the next video lecture. So for now, let's just compare it. Okay, so the invoice has a line. Okay, so the invoice has line. So this is the difference or the comparisons of an object-oriented, okay, using this one, UML and ER model. So for this course, we will be talking and focusing more on the ER model. Now let's talk about the object relational and XML model. So you've got a combination. So there is no standard definition of what capabilities or attributes define either an extended relational database management system or an object relational database management system, or the ORDBMS. Here, both are referred to as the external relational or extended relational. Okay, extended relational. So ERDBMS have a characteristics of both the RDBMS and an ODBMS. Thus, the loose application of the ORDBMS label. So ERDBMS products provide a relational data or data model and query language that have been extended to include many of the features that are typical to ODBMS. So extending the query language allows for the integration of a well-understood query optimization. So typically, a programming capabilities are embedded in the query language. So this capability is not to be confused with stored procedures that are provided by a number of relational vendors. So with ERDBMS, programmers are able to write functions in conventional languages as well as in SQL. So these functions can be embedded in standard SQL statements in exactly the same manner as DBMS vendor function. Example, cbase, getDate function. Okay. Also, we have the latest trends. Okay, so these are the emerging data models. This includes big data and NoSQL. Okay, so big data, you have heard big data before, okay, on our orientation. So big data challenges, volume does not allow the usage of conventional structures. Okay, that's why we are using big data or NoSQL. Okay, so big data challenges, aside from that, aside from voluminous data, okay, you've got expensive. Okay, so it is expensive. And all app tools proved inconsistent dealing with unstructured data. So the goals of big data is to find new and better ways to manage large amounts of web and sensor-generated data. This sensor-generated data came from the IoT, okay, or the Internet of Things. Okay, it provides high performance at a reasonable cost. So the characteristics of big data is, of course, the volume. Okay, volume pertains to the amount of data being stored. Velocity is the speed by which data grows and need to process data quickly in order to generate information and insight. And this data comes in different variety. So data being collected comes in multiple different data formats. Okay? Now, new technologies of big data, this includes Hadoop. Okay? Hadoop is a Java-based, open source, high-speed, fault-tolerant distributed storage and computational framework. So Hadoop Distributed File System, or the HDFS, highly distributed fault-tolerant file system designed to manage large amounts of data. Okay? MapReduce, open source application programming interface that provides fast data analytics. And the last one is NoSQL. Okay? So we are going to cover NoSQL on the next slide. Okay, so what is a NoSQL? Not based on the relational model. Okay? It supports distributed database architectures. It provides high scalability, high availability, and fault tolerance. So support large amount of sparse data geared towards performance rather than transaction consistency. So it stores data in key value stores. Okay? So NoSQL databases, aka not only SQL. Okay? That's NoSQL. Alright? It is NoSQL. It means not only SQL. Okay? So these are non-tabular and store data differently than relational tables. So NoSQL databases come in a variety of types based on their data model. So the main types are document, key value, wide column, and graph. So they provide flexible schemas and scale easy with large amounts of data and high user loads. So when people use the term NoSQL database, they typically use it to refer to any non-relational database. Okay? So some say the term NoSQL stands for non-SQL, while others say it stands for not only SQL. So either way, most agree that NoSQL databases are databases that store data in a format other than relational tables. All right? So a common misconception is that NoSQL databases or non-relational databases don't store relationship data well. Okay? So NoSQL databases can store relationship data. They just store it differently than relational database do. So in fact, when compared with SQL databases, many find modeling relationship data in NoSQL databases to be easier than SQL databases because related data doesn't have to be split between tables. Okay? So NoSQL data models allow related data to be nested within a single data structure. So NoSQL databases emerged in the late 2000s as the cost of storage dramatically decreased. So gone were the days of needing to create a complex, difficult to manage data model simply for the purpose of reducing data or duplication. So developers, rather than storage, were becoming the primary cost of software development. So NoSQL databases optimized for developer productivity. Okay? So there are several types of NoSQL as mentioned earlier. So these are the key value stores, column family stores, document databases, and graph databases. Okay, so what are these? So let's start with the key value stores. The main idea here is using a hash table where there is a unique key and a pointer to a particular item of data. So the key or value model is the simplest and easiest to implement. But it is inefficient when you are only interested in querying or updating part of a value, among other disadvantages. So examples of a key value stores includes the Tokyo cabinet or tyrant. Okay, you've got Redis, Voldemort, the Oracle BDB, the Amazon Simple DB, and the React. Okay, so the next one is a column family stores. So these were created to store and process very large amounts of data distributed over many machines. So there are still keys, but they point to multiple columns. So the columns are arranged by column family. So example of a column family stores includes Cassandra and HBase. So maybe you are not familiar with some of it, but these are the future trend in databases. All right. Okay, so the next one is a document databases. So these were inspired by Lotus Notes. Have you heard about Lotus Notes? Okay, so this is an old software. Okay, so these were inspired by Lotus Notes and are similar to key value stores. So the model is basically version documents that are collections of other key value collections. So the semi-structured documents are stored in formats like JSON. Okay, so document databases are essentially the next level of key value, allowing nested values associated with each other or with the key. Okay, so document databases supports querying more efficiently. So an example of a document database is a CouchDB and the popular MongoDB. All right. So the last one is a graph database. So instead of tables of rows and columns and the rigid structure of SQL, a flexible graph model is used, which again can scale across multiple machines. So NoSQL databases do not provide a high-level declarative query language like SQL to avoid overtime in processing. So rather, querying these databases is data model specific. So many of the NoSQL platforms allow for RESTful interfaces of the data, while others offer query APIs. So an example of this graph databases includes the Neo4j, the Infogrid, and the Infinite Graph. Now, let's talk about the NoSQL advantages and disadvantages. So NoSQL, highly scalability, availability, and fault tolerance are provided. So it uses a low-cost commodity hardware, supports big data, and it uses a key value model, improves storage efficiency. Disadvantages includes complex programming is required. There is no relationship support. There is no transaction integrity support. And in terms of data consistency, it provides an eventually consistent model. All right. Next, you've got a simple key value representation here. Okay. So this is tracks are as. Okay. So data is stored using the traditional relational model. This is how it looked like. Okay. So in the relational model, each row represents one entity instance. So each column represents one attribute of the entity. So the values in the column are the same data type. Okay. So in the key value model, each row represents one attribute or per value of one entity instance. All right. So the key column could represent any entity's attribute. The values in the value column should be of any data type, and therefore it is generally assigned a long string data type. So see, you've got different implementation of the database. All right. So this is a simple key value representation versus the traditional relational model. Now let's cover the evolution of data models. So how come we have a lot of data models? and how come we have presented all of it to you. Okay, so these are the evolution of data model. So starting at the list 1960s, you've got the hierarchical and network model, which we discussed from the early beginning of this video lecture. Okay, so comments on the hierarchical and network. So difficult to represent many to n relationships, hierarchical only, structural level dependency, no ad hoc queries, record at the time of access, and access path predefined navigational access. So in 1970s, the relational model was introduced. Okay? And then in 1976, you're not yet born yet, all right? So entity relationship was introduced. In 1978, you've got the semantic, which includes object-oriented and extended relational, or the RDBMS. And then 2009, all right, so this is the latest or the recent, okay, development or evolution of data model. You've got the NoSQL. Okay, so the NoSQL is a database of today's big data. So it addresses big data problem, less semantics in data model, and based on the schema-less key value data model. Okay, so NoSQL is best suited for large sparse data stores. But as what I'm saying, in information management, we are going to use the entity relationship. All right, so this is a good foundation on learning the NoSQL maybe in the future so that you can compare it. Okay, next, you've got the data model basic terminology comparison here. Okay, so if we're talking about the real world, okay, a group of vendors, okay, so example, vendor file cabinet. So file processing, it's a file. Okay, hierarchical, segment type, record type. In relational, it's a table. Okay, and on the ER model, we call it entity set. And on the object-oriented model, we use as classes. Okay, so presenting the comparison table of a different model or data model. Okay, so for the relational, it is something related or directly compared with the relational model. Okay, so table, entity set, you've got row here or tuple. Okay, table attribute. So in here, this is entity occurrence and entity attribute. Okay, so some of this model has advantages and disadvantages that we have presented. All right. Okay, so let's talk about the data abstraction levels. So data abstraction, we use the end user's view, okay, on the external model. Okay, on designer's view, they looked at the conceptual model. Okay, DBMS view, this is on the system model, okay, internal model, and then you've got the physical independence on the physical model. So the degree of abstraction is higher from network hierarchical going to the object-oriented and to the ER. Okay, now let's focus on this. Let's start with the external model. So the external model is the end user's view of the data environment. So ER diagrams are used to represent the external views. So external schema, the specific representation of an external view. Okay, so end user's view of the data environment. So people who use the application programs to manipulate the data and generate information. So ER diagrams are used to represent the external views as mentioned earlier. Okay, so the external data level, an external schema specifies a view of the data in terms of conceptual level. It is tailored to the needs of a particular category of users. So portions of data or stored data should not be seen by some users and begin to implement a level of security and simplifies the view of these users. So in the relational model, the external schema is also part of or also presents data as a set of relations. So examples, Students should not see faculty salaries. All right? So faculty should not see billing or payment data. So information can be viewed from stored data might be viewed as if it were stored in that manner. So GPA, okay, is not stored. It is calculated when needed. Okay? So not all data needs to be stored. All right? So applications are written in terms of external schema. So the external view is computed when accessed. All right? So it is not stored. So different external schemas can be provided to different categories of users. So translation from external level to conceptual level is done automatically by DBMS at runtime. So the conceptual schema can be changed without changing the application. All right? So mapping from external to conceptual must be changed, referred to as conceptual data independence. So this is the first level of security that can be imposed on various users on the system. All right? Okay, so this is an example of the external model. Okay, so let's take a look at the student registration. Okay, so a student may take up to 6 classes per registration. Okay, so a student enrolls, okay, in the enrolled subject, and then enroll is taken by a class. Observing these relationships between these entities here. Okay, a class is limited to 35 students. Okay, so a course generates a class. A class is taken by, okay, the courses to be enrolled, and the students are enrolled in these enrolled courses here. Okay, on class scheduling, a room may be used to teach many classes. So it's not just one class is using the room, right? So a room is used for a class, and then each class is taught in only one room. And each class is taught by one professor. So a professor teaches a class, and a class generates a course, right? So this is an example of external model. So again, we will be talking more about this on the next video lecture. So this is just an overview. Okay, so let's go on the conceptual model. So conceptual model represents a global view of the entire database by the entire organization. So the conceptual schema is the basis for the identification and high-level description of the main data objects. So it has a macro level view of data environment. So conceptual model is a software and hardware independent. So logical design, task of creating a conceptual data model. So this model, okay, defines what the system contains. This model is typically created by business stakeholders and data architects. So the purpose is to organize, scope, and define business concepts and rules. All right? So the conceptual data level, also referred to as the logical design or logical level, when the conceptual level is implemented to a particular database architecture. It hides storage details of the internal or physical level. So in the relational model, the conceptual schema presents data as a set of tables. The DBMS automatically maps data access between the logical to internal physical schemas. Okay? So physical internal schema can be changed without changing the application. Example, we may add or remove an index. So DBMS must change mapping from conceptual to physical. This is referred to as the physical data independence. Okay? So we will abstract the logical view as conceptual view using the entity relationship modeling, which is a database architecture independent. Okay. Now, going back to the example presented earlier, let's connect it. Okay. So conceptual model. Okay. So the student enrolls in, okay, enroll entity. Okay. And then enroll entity is taken by a class. Okay. So courses generates a class, professor teaches a class, and each class or a class use a room. Okay, so this is an example of a conceptual model. All right. Now, how about internal model? So representing database as seen by the DBMS mapping conceptual model to the DBMS. So internal schema is a specific representation of an internal model using the database constructs supported by the chosen database. Okay, so logical independence is changing the internal model without affecting the conceptual model. So hardware independent, unaffected by the type of computer on which the software is installed. So the physical schema of the internal level describes details of how data is stored, files, indices, etc. on the random access disk system. So it also typically describes the record layout of files and type of files, a hash, B-tree, flat, whatever. So early applications only worked at this level. So explicitly dealt with these internal details, example, minimizing physical distances between related data and organizing data structures within the file. Okay, block records, link, list of blocks, etc. Now the problem includes routine are hard-coded to deal with physical representation. Changes to data structures are difficult to make, and application code becomes complex since it must deal with details. So rapid implementations of new features are very difficult. That's a problem with internal data or internal model. Okay. Now this is an example of an internal model. So wherein you have to see the internal model of each of these attributes here. Okay, so for the professor, of course, the attributes of a professor includes the ID, last name, okay, prof initial, character, okay, so these are the data types, prof first name, okay, character, and take note that each of this entity has what's called the primary key. So we will be talking about primary key on the next video lecture. So for now, just take note that each of the table has a primary key. Okay, so a class here has a class ID, all right, room has a room ID, and course has a course ID, and so on. So the internal model pertains to the attributes of its entity here. All right, so it pertains to the implementation or how this entity will be implemented in a database. That's an internal model. Okay, so next would be the physical model. So the physical model operates at the lowest level of abstraction. So it describes the way data are saved on storage media such as disks or tapes. So it requires the definition of the physical storage and data access methods. So relational model aimed at the logical level. It does not require physical level details. So there is a physical independence. Changes in physical model do not affect internal model. So the physical data model, this is the model describes how the system will be implemented using a specific DBMS system. So this model is typically created by the database administrator and developers. So the purpose is the actual implementation of the database. All right. Now, let us compare the four. Okay, you've got the model here, the degree of abstraction, okay, each focus, and these are independent of. Okay, so external, the degree of abstraction is high. Same thing with conceptual. Okay, so physical, you've got low because you are almost on the hardware side. Okay, So the focus of the external is more on the end user's view. Conceptual is the database model independent. So global view of the data. Internal, a specific database model. And the physical, the focus is more on the storage and access methods. All right. So external is independent of hardware or software. Same thing with the conceptual. Internal is independent of hardware. And physical, neither hardware nor software. All right. Now, going back to our diagram presented earlier. Again, this is the diagram presenting the data abstraction levels. Okay. So, object-oriented, relational. Okay, you've got high degree of abstraction. So network and hierarchical, which is being less used nowadays in database modeling, is low in terms of abstraction. All right. So this is the end of this video lecture. See you on the next video. Have a great day.